All right, let's dive into two of the most powerful and, let's be honest, kind of confusing tools in a front-end developer's toolkit: debouncing and throttling. If you get these two concepts right, you can make your apps feel so much faster and smoother. So, let's break them down.
Okay, picture this. You've got a user on your website. They click on the search bar, ready to find something. Pretty standard stuff, right? They start to type a word, let's say matrix. But what's happening behind the scenes is, well, a total mess. That single 6-letter word just fired off 6 different requests to your server. Yep, one for M, another for MA, then MAT. You see where this is going. It's an absolute stampede of API calls for just one search.
So why is this a big deal? Well, for one, you're hammering your server with a bunch of useless requests. And for the user, especially if they're on a shaky connection, the UI can start to feel laggy and just weird, with results flashing in and out. It's just not efficient, and we can do way, way better.
So how do we get a handle on this madness? How do we tame all these events firing off at once? Well, this is where our two heroes of the day come into play: debouncing and throttling. Two different strategies to solve this exact problem.
Let's kick things off with our first solution, debouncing. And honestly, the best analogy I've ever heard for this is to think of a polite waiter. They don't sprint to the kitchen after every single thing you say. No, they wait for you to finish your entire order before they go and do anything.
So, in more technical terms, what debouncing does is it bundles up a whole flurry of events into just a single one. It works by making sure a function, like our API call, only gets to run after a certain amount of time has passed without any new events coming in. It's all about waiting for that quiet moment, that pause. And that right there is the key. If you're going to remember one thing, it's this simple idea: wait until the user stops doing something. The waiter waits for you to stop talking. The debounce function waits for the user to stop typing. Simple as that.
So let's trace it out. The user starts typing, right? That kicks off a timer. But, and here's the magic, every single time they press another key, that timer gets completely reset. It's canceled, and a brand new one starts. This just keeps happening over and over until the user finally pauses for a second. Once that delay, maybe 300 milliseconds, goes by without a new keystroke, then the timer finally finishes and that one single API call is made.
And that's really all there is to it at a high level. The core logic is this elegant little dance between clear timeout and set timeout. You're constantly clearing the old plan and setting a new one. As long as the user keeps typing, that function inside the set timeout just never gets a chance to run.
Okay, so that's debouncing, our patient waiter. Now let's meet our second solution, throttling. And if debouncing is a waiter, you should think of throttling as the bouncer at a popular club. That bouncer doesn't care how long the line gets. They're letting people in at a steady, fixed pace, one every few seconds, no matter what.
And that's pretty much exactly what throttling does in code. It guarantees that your function will run at most one time during a specific window of time. So you could have an event fire 100 times in 1 second, but if your throttle interval is set to, say, 500 milliseconds, your function is only going to run twice, period.
So the mental model here is just as simple. Run this at a controlled rate. You're not waiting for anything to end, you're just putting a speed limit on how often something can happen. This is perfect for stuff like infinite scroll, or tracking the mouse position, or resizing a window. You want those updates for sure, but you don't need 1,000 of them every second.
Let's use infinite scroll as an example, right? The very moment the user starts scrolling, the function runs immediately. But then a cooldown period kicks in. Let's call it 500 milliseconds. During that cooldown, any other scroll events that fire are just completely ignored. They don't do anything. Once that half second is up, the function is allowed to run again, and the whole cycle just repeats. You get this nice, steady stream of updates, but at a rate that's actually manageable.
All right, we've met the waiter and we've met the bouncer. Now it's time to put them side by side for the final showdown. This is where we really lock in the difference and figure out which one you need for your specific problem.
This table really nails it. First up, execution. Debounce waits for you to stop, throttle runs at a fixed beat. That means the frequency is different too. Debounce runs only once, after everything's done, while throttle can run many times, just at a slower rate. But honestly, this last row, user intent, that's the one that matters most. You use debounce when only the final result matters, like the full search term. You use throttle when continuous feedback is what's important, like showing where the user is on a long page.
So let's make this super practical. You're going to reach for debounce when you want something to happen after the user is done. Think search bars, form validation that only runs after you've clicked out of a field, or an autosave that waits for you to stop typing.
Throttling is your go-to for events that fire like crazy. We're talking infinite scroll, resizing the browser window, or tracking an element that's being dragged across the screen. Okay, so you get the theory now. But knowing what they are is one thing. Actually using them in the real world without causing new problems, that's another. So let's cover some pro tips and common traps that people fall into.
Here are a few things to watch out for. First, especially in frameworks like React, if a component disappears before a debounced function has a chance to run, you can actually create a memory leak. You've got to remember to cancel that timer. Second, a bad user experience. Don't use debounce on something like a volume slider. The user expects to see the change happen immediately, not after they stop dragging. Third, with throttling, remember you are purposefully ignoring events, which means your data might be slightly out of date between updates. And finally, don't forget that you can often configure these to fire at the beginning or the end of the event flurry, which can make a huge difference.
So what if this question comes up in an interview? Here's how you give an A+ answer. First, nail the core difference. One waits for a pause, the other just slows things down. Next, talk about the trade-offs, how you're balancing a super responsive feel against back-end performance. Then, to really show you know your stuff, mention those advanced options like leading versus trailing edge execution. And finally, bring it all home with those perfect clear examples. Search for debounce, scrolling for throttle. You do that, and you've nailed it.
And that really brings us to the final thought I want to leave you with. We know what they are and when to use them, but the next level is thinking about how we use them. We just mentioned that you can have these functions fire at the leading edge, the very first event, or the trailing edge at the very end. How does that one little choice totally change how an interface feels to a user? That's your homework. Thanks for tuning in.